All right, so let's see. 2x minus y less than 5. All right, so we got to get y alone. Same thing, back to the shading thing. We got to get y alone. We just did it real quick right before the break, huh? So remember what we did. See if you can do that again. A little different numbers here. Get that y alone. So here's the wall. So y is saying I want to be alone. What's the first step? Good. Subtract 2x from both sides. These cancel. Minus y. Minus 2x plus 5. We good so far? Everybody good to there? Now, we have to finish getting y alone, right? Yeah, we got to get rid of that minus sign. Right? So we got to get rid of that minus sign. How do we get rid of that minus sign? Yeah, I'm sorry. You said it, yes. Yeah, you divide through by that -1, and then that flips the symbol, right? Everybody good with that? Right, so flip that symbol the other way, right? Whenever we divide by a negative, so let me write that, divide by negative, you've got to flip the symbol. So we flip the symbol. What do we get then? We get y greater. Now, what happens on the other side? What is -2 over -1? Positive. Two negatives make positive, huh? And what is positive over negative? Negative. Is that good? All right, now we're ready to graph the thing, right? So can you graph it from there? Give you a second, graph that thing, and then decide the shading. And you always decide the shading from the last line, not the first. It's when you got y alone. So well, tell me right now, what's the shading going to be on that when we eventually get the line? We're going to shade above or below? Y greater, above, huh? Yeah, so it's when y is alone, you just circle y, and whatever symbol is next to the y alone, that will tell you the shading. Okay, where do we start? Yeah, start down 5. 1, 2, 3, 4, 5. Right there. Down 5. There's the first dot, and then where do we go from there? 2 over 1, huh? Rise, over run, up 2 over 1. Up 2 over 1. Does that make sense? Up 2 over 1. All right. So is this going to be a solid line or a dotted line? Yeah, it's not. It's no equals. So we don't want the line. We can only do it dotted. Like that. That makes sense. We good like that? And then which side do we shade? Yeah, we're going to, it says y greater. Yeah, this is the side above, huh? This is the side below. You can tell by this, that's a big W there, by the slant of the line. So the stuff above is here. So there we go. Does that make sense? We good? You guys good at these? There's 4. I was looking at the practice. I think there's 4 of these on the practice exam. Therefore, similar on the real exam. And it looks like you can do them. All right. So was it A, B, C, or D? Yeah, it's B, huh? That's how it'll be on the real thing too. Multiple choice like that, right? You need to be able to grab that easy enough. B it is. Straight out, easy enough. Okay. All right, try number 6. So I want to solve, same kind of thing, solve for y, right? Y said I won't be alone. So here's the wall. Y is saying I won't be alone. First step. Add 5x to both sides. Good to there. How do you get y alone? Divide through by 4. And then that's 5, huh? So we make this a whole number, but we leave that one a fraction. All right, time to graph. Let's go ahead and graph that thing. You guys have done a lot of graphing in these last 2 days. So we start at up 5. So, is that right? Oh, these are small. I don't know if I can even do it. So tiny. And I missed. I'll make it bigger. No, I can't make it bigger. Oh, I'm on the eraser. All right. So started up 5. There we go. And then rise 5, run 4. So from there you go up 5 over 4. I don't even know if I can find that spot. Somewhere like around there, huh? I was going to guess. It's pretty close. I think I'm a little low. Anyway, do the line like that. I'm going to do the best I can.
That was just horrible.
Yeah.
You want us to do the line like that?
Yeah, just do a line like that.
Exactly.
Yeah, it's exactly like that. And we need to make this thing dotted, huh? Oh yeah, there we go. Hey, some of my finest work. All right, there we go. There we go. All right, so we're going to shade above it or below it. Shade which side this is above over which side this is the side above it. This is the side below it, huh? Which side are we going to shade? What does it say? This says, looking back to the symbol, y is greater. Y is greater. So shade above. Shade above it up there. Dotted line shade above. Jose.
So this is just equal or greater or vice versa, right? It's not. Oh, I'm sorry. Greater or equal, but not equal. If it gets to equal, how do you,
You mean, okay, if they said y greater than or equal, like that.
or y equal?
Okay, hold on. First off, this would mean, what would I do if it says greater or equal?
Solid line.
Solid line, good. Now, what if they just said equal? That's your question, right?
Yes.
What if they just said equal? Only the line, no shading.
Oh, okay.
Everybody get that? Because remember, the line is the equals. Remember the three territories? This is the equals, this is the above, this is below. So if they only want the equals, they only want the line. They don't want the shading greater or the shading less. Make sense? But if they want greater and equal, well, then you want the shading and the line. If they just want greater, then they just want the shading, dot the line. Good? So just remember it's three different zones. Above, below, equals. Right on the line. All right. Good. All right, so try number 7 there. Two x plus 3y less than or equal to 6. Try that. So y is saying I want to be alone. Subtract the 2x on both sides. Here's the wall. Final step is divide by that 3, huh? So what do we got? Minus 2/3 x plus 2 on that. Okay, where do we start? The graphing started up to right there, and then rise over. What do we always do with the negative sign on a fraction? Put it on the top, right? It's not on both. Two negatives would be positive. It's on the top. So put that negative on the top. So go down 2, 1, 2, over 3, 1, 2, 3. Boom, there we go. 2 dots. We good to there. Connect the dots. Solid line or dotted line?
Solid.
Yeah, because we want the equals this time, don't we? So solid line. Now this is above. This is below. And of course the line is the equal. So the three zones. So what do we want? We want the lesser zone and the equal zone.
Yes.
So below and solid line equals. There we go.
Below always equals less.
Yes, less is below, greater is above. Exactly. All right. So, great. Okay, so number 8. Try that one. See if you can handle it. I won't say anything. See what you can do. They're throwing you a curveball. It's all of a sudden weird.
There's always a curveball right there.
That's right. Couple fastballs, and then comes the curveball. All right, is y already alone? Yeah, really, there's nothing technically to move around. Y is already alone. Let me bring it over here. Y really is alone. Okay, but how do we start? I mean, right, we got y alone and everything, but there's no number out here and there's no fraction in front. I mean, what did we do? Yeah, this is where we do some fancy plastic surgery, right? Remove the wrinkles. We make it look different without being different. I would like to put something multiplied by the x without changing it. I would like to put something added out here next to the x without changing it, right? You got to do some multiplying and some adding that won't change anything, right? I can't go multiply by 7 and add 49. No, that would change it, right? I mean, that's not okay. That's different. So what I got to take that x. What number can I times that won't change anything? 1 over 1. Because that's just 1. 1 times x is just x. What number can I add that won't change anything? 0. Yeah, 1 is 0.99 forever, right? No, it is, but we won't do that. All right, so there we go. Does that make sense? You got to put in the understood stuff, the stuff that won't change anything. Now you can graph it. That was the curveball. Now you're ready to hit that pitch, right? Where do we start?
0.
Start at 0, which is right on the origin. Start at 0, right? And then where do we go from there? Up 1 over 1, rise and run. Go up 1 over 1. So there's the other dot. Oh, is it solid or dotted? I forgot. All right, I'm going to dot that line. Yeah, because it doesn't say equals, huh? So here's the above, the less or below, and then there's the equals right on the line, right? There's above, below, and equals. Now, look carefully at the y. Let me give you a second. Try to figure out the shading on your own there for a second. If you have not, I want you to think about it's valuable. Decide which side should be shaded. Yeah, so you always want to read the symbol from y's perspective. What side of the symbol is the y getting? The greater side. Good. We all good with that? That's good. That is correct. Yeah. Y is greater. He's on the wide mouth side, huh? Y is greater. Where's the greater stuff? Above. And dotted line because we don't have the equals. There's no equals. And there we go. Is that good? So to put in the understood 1 over 1 and the plus 0. And y greater. They had things turned around a little bit for us there. Can you handle that okay? Especially on the exam on Friday? Good? All right. We'll move ahead. That was number 8. Y greater than or equal to negative x. Try that one. So you got to put in the understood stuff again. So 1 over 1 and add 0, huh? Right? Because 1 over 1 is just 1. 1 times x is just x, and adding 0 doesn't do anything either. All right, so we start at the 0, the origin. We good? Start at the origin. And then rise over run. So, what do we do with a negative on a fraction? It only goes on the top, huh? Remember, a minus on the fraction, you only put it on the top. You always leave the bottom positive, right? Because 2 negatives, to put it on both would be wrong. 2 negatives is positive. That can't be right. So we just put the negative on the top. So that means you go down 1, over 1. There's your other dot. Good to there? Solid line or dotted line? Yeah, we have the equals. So it's greater or equals. So solid line, because that's the equals. Over here is above the line. Over here is below the line. So which side are we shading? Above the line. Shade above the line. Shade greater. We good? Questions on that? He's getting easy now. You can do these in your sleep. All right, try that one. See what you can do to shade that, to graph that. Okay, so what kind of line is that? When it only has one letter, it's going to be perfectly straight somehow. Either perfectly sideways or perfectly vertical. It's not normal, right? So only, let's make sure we're clear with that, only one letter, it's going to be vertical or horizontal, right? How do you know which? Well, go to the x-axis and put a line through at 5. You with me? This is the x-axis. Put a line at 5. Is it going to be a solid line or a dotted line? Dotted. At 5. Right? It's less, not equals, huh? So that's why we have the dotted line, because it's right, because this is the equals stuff. The line is always the equals, and we don't want the line on this one. Which side? Everybody good first off with the line, right there at 5, right? Going through x is 5, the x-axis at 5. Now, should the shading be to the right or the left? It's weird, because we can't really say above and below, can we? That line's not, it's not tilted at all. So what's above? What's below?
To the right?
Yeah, we don't even have a y at all, do we? There's no y at all. So you can't really think above and below. That's a y kind of concept. That's an up-down kind of concept, isn't it? We only have x. All we can think is right or left. So this is the right. This is the left. What does this say? X less. Where's the lesser stuff on the x-axis? Where's the lesser numbers? Over here. To the left, huh? Does that make sense?
And that will include even over the,
Yeah.
the y line, right?
Yep.
M.
Everything to the left. Yep. Because all the numbers less than 5. So that'd be 4, 3, 2, 1, 0, -1, -2, -3, -4. All things less than 5. With a dotted line because we don't want the equals. Is that good? So when there's only one letter, those are always vertical or horizontal. There's like 4 or 5 of those on the exam. You know, with only X or only Y, right? And those are always vertical or horizontal, aren't they?
It was like the same thing when it was like x equals.
Yeah. When it was X equals 5, it was just a straight line, no shading, huh? In that case. Yeah, so the greater than less than is what does the shading. Everybody good with that? And you'll see that on the test multiple choice, so you'll look down, they'll all be shaded. And you go, oh, yeah, it's the greater than less than, of course. Yeah, so it's the greater than less than that makes the shading. It's the equals that makes the line. Huh. Good? That, on the practice exam, it often goes like this. Well, here's like number 1 on the practice exam. Graph that. So go ahead, graph that real quick. Make sure you're okay with that. Yeah, same thing. Lots of graphs. All right, so what do we do first on that one? What does Y always want to be? Alone. Yeah, that's the part I wanted to make sure, that you realize you've got to get Y alone first. Then it'll all be fine. Yeah, so first get Y alone, right? Don't ever forget that. See, on the why want to choose? Because the last couple, do you notice they already gave the Y alone? So I don't want you to get lulled into thinking you can always just look at that number and go for it. No, not unless Y is already alone, which it was. The last two, and that one, the X was already alone. So I'm getting nervous that they're just giving you too many that are already set up for you. So this is what's on the exam, the practice exam, I mean. Number 1, Y is not alone. So if it's not alone, you got to do that first, huh? So don't forget that. Do that first. So get the Y alone, then it'll all be good. So that's subtract 7 from both sides, and we get Y equals, what's that, -7. Then we go to the graph. So we have the x-axis and the y-axis. Where does it go through the y-axis? Down 7. 1, 2, 3, 4, 5, 6, 7. So here's down 7. And is it going to be a horizontal line or a vertical line? I mean, that was a dumb question. It's going to be a horizontal. But I mean, is it a solid line or dotted? Yeah, it's just solid. And there's no shading on this one, huh? Because there's no greater than less than. That's what makes the shading. They only want the equals. They only want the equals line. They don't want the above. They don't want greater. And they don't want the below. They don't want less. They just want the equals. They just want the line. Y equals -7. All right, I think you've got all that graphing stuff down solid. Solid as a rock there. All right. Well, that's the exam on Friday. You can take that thing right now, huh? I'll go get it. It's in my office. You ready? No. I know, probably you'd be fine, huh?
Rip the Band-Aid off.
We'll do the what's that?
We'll rip the Band-Aid off.
Yeah, just tear it off. Tear it off. We're ready to go. No, I want to be sure when we rip that thing off there's health underneath. So tomorrow we'll take a practice exam and we'll go over it to see if we indeed are ready. Because it's just easy. Little things can slip by you. So tomorrow practice exam, Friday real exam. All right. So this is not on Friday's exam. This will be next week's exam. All right, determine whether 7 is prime, composite, or neither. Have you heard of this kind of thing? What's a prime number? What's a composite number? You heard of that before? So we're getting into chapter 5 now.
The prime number can only be divided by itself, right? Or is that,
Yeah, you got it. You got it. That's a prime. Prime, yeah, the primes only divide by 1 and themselves. Because everything can divide by 1. Yeah, 1 and themselves. Nothing else. And the composites can be divided by other numbers. So that's the deal. Primes can only be divided by themselves and 1, and composites can be divided by them. So let's make a list of some of them. 1 is a special. I'm just going to set 1 aside for. Let's start at 2. Is 2 a prime? Am I going too quick here? Prime or a composite? Can 2 be divided by anything other than itself and 1? No, it's prime. 3. Does anything else go into 3? No, it's prime. 4. That's a composite. Let me slow down for just a minute. Make sure we're all caught up and this is making sense for you. So composite means you could break it down in other words. How about, here's another way to say it that might make more sense. What times what is 4? 2 times 2, yeah. If there's some way to break down the number, then it's composite, right? 4 is 2 times 2. Do you see? Because that means it's composed out of 2 2s. 4 is just a Johnny-come-lately. He's just made out of 2s. He's not a prime. He's not a main thing that makes all the other numbers. Whereas 1, 2, and 3, they're prime. Nothing makes them. They are unique, right? Like how you might say, well, you can do 2 1 times 2. Well, you had to use the 2 again. That's not making it out of other things. See what I'm saying? Same thing with 3. Only way you can get 3 is 1 times 3, huh? Does that make sense? Whereas 4 is just composed, right? Like they talk about, like the wood at the top of this table here. Think this is real wood? No, all these kind of woods now, is composite woods, right? Which means they've taken a bunch of woods and they just smashed them together in the lumber shop, right? Because it's cheap. They didn't take an actual piece of oak or an actual piece of whatever and fir tree and just make it all. That's expensive, right? This is just a bunch of sawdust that was laying around, or a bunch of extra wood, and they just press them. They call them composite wood, right? It's composed out of several kinds of wood just smashed together, right? Well, that's what we're talking about, composite numbers. They're just made out of other numbers. Like 4 is just made out of 2 times 2. He's not unique. He's not pure. How about that? That's a good word. He's not pure. Yeah, prime's like pure. And all right, let's keep going. How about the next one? We have 2, 3, 4. How about 5? Is 5 prime or composite? Prime. Can't make 5 out of anything else. He's pure. 6. Yeah, he's composed out of 2 times 3. 7. Prime. Pure. 8. Any other even numbers? 8, 10, 12, 14, 16, 18, 20, 22. What are those even numbers all made out of? 2 times something. Because they're even. Right? That's what it means to be even. You're divisible by 2. Right? Pick any even number you want. 24. That's 2 times 12. There's other ways to write it also. But at the least you could say it's 2 times 12. So you know what I mean? So there's no more even pures. There's only one even pure number. 2. All the rest of the evens will for sure be composed out of 2 times something. Right? Don't even need to check those. I got to check the odds. Don't need to check the evens anymore. They're all the other evens are for sure composite numbers. Now the odds will go both places. Some odds will be prime, some odds will be composite. It'll go back and forth. But the evens, the rest of the evens are all composites, aren't they? Does that make sense? We good with that? Let's go on with the odds then. Joel, do you want to say something?
No, you answered it.
Oh, okay. How about the next odd number? 9.
Composite.
Yeah, it's down here. He's not pure. He's just made out of 3 3s. Right? 3 3s make a 9. How about 11? 11's up here. He's pure. Prime. 13.
He's prime.
Pure. Prime. Nothing else will make a 13. Can't make 13 by composing 2 other numbers. 15.
He's composite.
What's he made out of?
3 primes.
3 times 5. 3 5s. Make 15. He's just made out of other stuff. He's not pure. 17.
Prime.
Prime. 19.
Prime.
Prime. 21.
Composite.
What's he made out of? 3 times 7. 23. 25.
Composite.
What's 25 made out of? 5 times 5. 27.
Prime. Oh, he can, 4
Nine.
times.
What is it?
3 times 9.
27 is 3 times 9.
Yeah.
29.
Prime.
Prime. And on we could go. We're tired of this now, right? So, but you get the flavor, right? All the other evens, I didn't list the rest of the evens, right? 10, 12, 14, 16, 18, 20, you know, they're all down here too, right? 22, 24, you know, on you go, da-da-da. All the other evens, right? They're all 2 times something, right? So, composite numbers, prime. Which ones are there more? Yeah, there's more composites, right? The primes are more rare, right? They make all the other numbers, right? They're like that. I was looking around for a periodic table. There's not one in here. But it's like the periodic table, which is the chemicals that make all the other things, right? Right? You with me, right? The certain things make other things, right? Like all biological life is made out of what? Carbon. We're called carbon-based life, right? We're made out of a lot of carbon and other things too, but a lot of carbon. So everything's made out of, so that's kind of like what the primes are like. They're the building blocks that make everything else. That's what the primes are. They have a special role in the numbers. Yeah. Do the primes keep going forever?
Yes.
Yeah, they actually do. They go forever. Yeah. And so do the composites. They both go forever. But the primes are more rare. Okay. So with all that said and done, the question is 7 prime, composite, or neither? Prime. 7 is prime. Okay. So 46. Is it composite? How do you know right away it's composed out of other things? Yeah, it's 2 times 23, isn't it? Yeah, any even number other than 2. There's only one even prime, huh? And that's the number 2. 2 is even. Yeah, so this would be a composite. Yeah. Oh, I didn't tell you about 1. Is 1 prime or composite? It's actually a trick question. It's neither. Did you know that? Did I hear neither? Did you know that? 1 is neither prime nor composite. Makisha, how'd you know that?
Because they kept saying neither, so obviously something had to be neither.
Yeah. Yeah, it's neither prime nor composite. Good observation. Yeah, he's special. Now you might think, well, he's prime. Nothing else divides him. Yeah, I'm just trying to be a little casual to make it easier, but the formal definition, the more official, like if you look on Google or something, a prime number, it isn't just the little thing I said. I'm trying to make it as simple as I can. But really, prime means, excuse me, exactly, excuse me again, exactly 2 divisors. And composite, the technical definition, is 3 or more divisors. That's the technical definition. Now, what do we mean by that? Well, a prime number is a number like 7 because exactly 2 things can go into 7. What 2 things? 1 and 7. 1 and 7, right? You can divide it by 1 or you can divide it by 7 and it'll be clean. Either way, right? 2 numbers divide into 7. 1 and 7 because 1 goes into everything. Right? So if you have exactly 2 things that go into you, exactly 2, not 1, not 3, exactly 2, then you're prime. Okay? And a composite is when you have 3 or more, like 10. 10 is composite. Why? What? There's 3 or more things that go into 10. What can 10 divide by evenly? Well, 1 and 10, of course. And what else? 2, 5. It's got 4 things. So that makes it composite. That's the technical definition. Composite means 3 or more things go into it. Prime means exactly 2 things divide into it. So do you see why 1 fits in neither category? How many things go into 1? Only 1 divisor. So he doesn't have 2 divisors, and he doesn't have 3 or more. He only has himself. 1 is the only lonely number, as the song says. 1 is special. He's neither prime nor composite. All right, so there's all that. That's a lot of formality here, a little bit of number theory.
Would that be the same thing for like 0, I guess?
Yeah, well, we're just considering numbers 1 and on up. Yeah. So we wouldn't do the negatives, we wouldn't do fractions. We're just talking about what's called the natural numbers. That means 1 on up. What do you think about 71? Yeah, use your calculator. If you're not sure, use your calculator. Divide by 2, divide by 3, divide by, and nothing will go in. So then it's prime. Nothing divides cleanly. Nothing divides cleanly, so it's prime. Is that good? It's a prime number. If anything else divides, then it's composed. Composite number. I'm going to break down. You guys have your calculators with you? Break down 625. So I'm going to take 625 and kind of break it down. It's really made out of a bunch of primes. Let's break it down. Now, if you have your calculator, what do you know? It's a big old number. What do you know right away? Even though you don't know everything about the number, that's fine. What do you know for sure goes in?
5.
Good, because it ends with a 5, huh? So divide by 5. You use your calculator, you get 125. So right away you go, oh, I can break that 625 down into 5 times 125. Does that make sense? 625, I just divided it by 5. Now, let's keep going. The 125, you can break that one down.
25.
Yeah, 5 goes into that as well, huh? Take your calculator, 125 divided by 5, or $1.25 is 5 quarters. 5 quarters makes $1.25, doesn't it? 5 times 20, right? We do money all the time, so we know money pretty well. 5 times 25 is $1.25. Now you can break down the 25. Five and 5. And that's the breakdown. These 4 5s are the guts of a 625. Alex,
Just to separate by commas?
use commas to separate answers. Oh, I'm doing prime factors. I am wrong. Yeah.
What will go into 625?
I don't want to do that. All right. Yeah, you're right. I'm doing something different. They want me to do something. I'm trying to, okay, what's the easy way to do this? Yeah, I'm doing the wrong thing. We're going to do this in a minute. This is what's important right here. But anyway, they want me to do this other dumb thing. So they want me to do all the things that go in, not just the primes. I was finding just the primes. All right. So I'm trying to think, what's the easiest way to do this? Should we just start with 1?
It took the answer with 1.
Yeah, I mean, I know what the answers are. I'm just trying to think, what would be the easiest way to help you guys always get there? Yeah, just start dividing by 1. Yeah. All right, so just start 625, and then just take the number and just divide by 2, 3, 4, 5, 6 with your calculator. Just start breaking it down. So when you divide by 2, it doesn't go. It's not a clean answer. Divide by 3 doesn't go. 4 doesn't go. 5 gives you the 125 answer. You with me? So then right away you go, okay, 5 times 125. You with me on that? So I've taken 625 and I'm just starting to divide by things. Well, you knew 5 went in, right? So you break that down, and then you break down. I don't know why this seems. There's some easy way. I'm trying to do this easy, and I don't remember how to do it easy.
I did it the way you did it at first, and then just added 1 and 625.
But it didn't accept that when I put it in because it asked for another answer.
You got 1, 5, 25, 125, 625?
Yeah.
Oh, took mine.
No, that's right. You're right, Alex. That it should take that.
Yeah, I know. We didn't mention 25.
Oh, right. Yeah. So she's saying she put everything in the list, right? So if you go back to the I erased it, didn't I? It's gone. Yeah. So yeah, that's good enough. All right. I'm trying to do a way that's always going to be complete, but I don't know. I don't like these questions. These are kind of dumb. All right, let's go back and do it that way, I guess. So 625, break it down again, divide by 5. 5 times 125, divide by 5. 5 times 25, divide by 5. 5, 5. So basically, yeah, every number that's up there is what it is. So 125, 25, 5, 625, and the 1. So because what they're wanting on this question, and you can put it in any order, doesn't matter. What they're wanting on this question is all the different numbers that divide into 625. Those are all the numbers that will go evenly into 625. Is that good on that? Questions on that? All right. Real story. I didn't want to do all that, but we have to. There's no shortcuts. I tried shortcutting and it didn't work. So let's take the 96. So what are you going to do to find all the factors of 96? You're going to divide by 2, 3, 4. How far are you going to go? Let's find that out right. What's the square root of 96? It's 9 something, right? Yeah, 9.7, blah, blah, blah. So that means stop after 9, basically. Does that make sense? So, divide by 2, 3, 4, 5, 6, 7, 8, 9. Whatever you found up to there, that's all of them. After that, they would just repeat. Don't go past 9.7, so don't go to 10. You're with me? Seeing how to do this? Just take your calculator, you divide by 2, 3, 4, all the way up to the square root of the number. You getting them? I got them written up there. We're just trying to find all the numbers that go into 96, that divide evenly into 96. So 96 and 1, remember you always start with the entire number. The order doesn't matter, just in the list somewhere. It's got to be the entire number and 1, right? Because 96 goes into itself, clearly, and 1 goes into everything. Right? We're trying to list all the numbers that divide evenly into 96. So that's going to include 96 itself and the number 1, right? You with me? And then all those other numbers. So 2, 48, 3, 32, 4, 24, 6, 16, 8, 12. There they are. Order doesn't matter. Is that good? Is that making sense now? Like you can do that okay? Those are all the numbers that divide evenly into 96. There are no others. All right. Let's keep going. Here, you can use calculator though. 2. So we're going to take like 1114 and ask, can it be divided by 2? Can it be divided by 3? Can it be divided by 5? I bet you know these tricks already, at least some of them, maybe all of them. How do you know? Of course, you can just use calculator too. You can use calculator test. But can you tell just by looking? How do you know if 1,114 is divisible by 2? What it ends in. It's all about the ending, huh? Yeah, if it ends even, and what does even mean? 0 is even, 2, 4, 6, or 8, right? If it ends even, 0, 2, 4, 6, or 8, then yes, it's divisible by 2 when it ends even. That's the rule for 2. How about for 3? Does anybody know the tricky rule for 3? Joel, do you know it?
Yeah, add on.
You guys know this? I'm impressed.
You gotta add on.
When did you guys learn this?
Mr. Yang taught us that one.
Oh, you have Mr. Yang
Yes.
for Math 260?
Yes.
Excellent.
He said you add them all up and.
Yes. Yes, exactly. You add them all up. Nice. Yeah, meaning you add 1 plus 1 plus 1 plus 4. Melody, did you have Mr. Yang too?
No, I remember that from elementary school.
Okay.
Yeah.
Yeah, add them all up. So what's that? 7? 4, 5, 6, 7. And is 7 divisible by 3? No. So neither is the entire 1,114. It's a little trick you can do for 3. It actually works for 9 as well. It doesn't work for other numbers. You just add the digits up. It's kind of a weird little trick, huh? Just add up the digits, you get 7, and say, well, 7 divisible by 3? Not cleanly. Doesn't go in evenly. So then 1,114 is not even. Just like that. It's a little trick for 3. Anyway, you can just use your calculator, and it would tell you no. You know. How about 5? How do you know just by looking at 1,114 divisible by 5 or not?
And then 5 or something.
Yeah. If the end, again, it's the end 5 or 0. So no. 5 or 0. If the end 5 or 0, divisible by 5. So that was no. Good? You can just spot them that quick. Or you can just use your calculator. Okay, so 1356. Is it divisible by 2, by 3, or by 5? So try 2 first. Let me, don't shout it out. Try it on your own paper there. See if you can figure out 2, 3, or 5.
Kind of nice, we went from really hard stuff to really easy.
Yeah. Fancy stuff made easy. Impress your friends at social gatherings.
Always.
Yes, that's what I do. I don't know why I don't have many friends. All right. Divide by 2. So divisible by 2?
Yes.
Yes. It ends even. Even. So that one's a yes. How about 3?
Yes.
Yeah, you add them up. 1 plus 3 plus 5 plus 6, 11, 12, 15. Is that divisible by 3? Yes. 3 goes into 15, so 3 goes into 1,356. Know it that quick. Goes in evenly. How about 5?
No.
No. It ends not with a 0 or 5. That good? Quick and easy? I don't know if that's quicker than a calculator or not. All right. This I'm willing to spend some time on because it's important and we'll keep using it throughout the rest of math. But not that other crazy thing. All right. Now this sounds a lot like that other question. There's one key word that's different. Prime. They're not just saying find all, so if you look back here, let me go back. List all the factors. See that? They didn't say prime. They said everything, right? All these numbers that I circled here are not prime. These numbers are not all prime. Most of them are not prime. They're not pure. 8's not pure. He's made out of 2 times 4. 12's not pure. He's made out of 2 times 6. But they didn't say just give me the pure ones. I wish they had. They said give me all the numbers that divide in. That's why I had to do that big old long tedious thing, right? Which is really unimportant because really all we care about is the prime ones. Those are the only ones that really matter. Now they're saying what I want them to say. Tell us just the prime ones. Just the prime ones. Okay, well that's where you do the tree thing. When they want just the prime ones. You don't have to do like divide by 2, 3, 4, 5, 6, 7, all that mess. That finds all the factors, which really we don't care about. We care about the prime ones. So how do you use? You just say, okay, what times what's 22? 2 times 11? Okay. Can you break those down any further? Does like anything, what multiplies to be 2? Well, just 1 times 2, and that's using 2 again. That didn't really get any smaller, so don't do that. What breaks down to be 11? 1 times 11, again, that's not smaller. So we're done. So what is the prime factorization to 22? What is the breakdown, in other words? What are the primes that make 22? 2 times 11 makes 22. That's all they want. They want the building blocks that make the thing. Primes make all the other numbers. That's why they're prime. They're the main attraction of the number system. Is that good on that? All right, so 65. So use your calculator, break it down, see what that's divisible by. Break down, that's 65. What times what's 65? 5 by 5, 13. So that, and that doesn't go any further, so that's it. Break down to the 65 is 5 times 13. Is that good? Let's keep moving.
Oh, you gotta put a multiplication, not a comma.
Oh yeah, they want a little times dot in the middle. Yeah, good point. They're picky here. They want a times dot. I'll show you. Let's do this one. Take the 90, same thing, break it down. Start breaking down. What times what's 90 and just keep on going. All right, what times what's 90? There's a lot. You can go 9 and 10. With things that end with a 0, it's just times 10, huh? 9 times 10. But you could do 3 times 30, 2 times 45, 5 times 18. There's a million ways to go. You just calculate, do whatever you want. But you got to keep going. What times what? 9 will break down further, huh? What times what is 9? 3 and 3. And what times what is 10? 2 and 5. Now, does the 3, 3, 2, 5 break down further? No. Those are primes. See how we keep going till we reach prime level?
Yeah.
These are all primes and won't go down further. Those are prime numbers. They're pure. They can't be broken down. So what's the breakdown of a 90? 3 times 3 times 2 times 5. That's the guts of a 90. It's like we're doing biology here. We're cutting open the frog and looking at his innards. That's the innards of a 90. That's what makes a 90. 90 is made out of those primes. And in fact, when you have a repeated one like that, you know what we do? 3 squared. Right? You know that little 2 in the upper corner means 2 of them, right? So that's how they really want you to type it in. And you have to put time. I'll go on the screen and show you the time dots. Like Kyle was saying, you got to put those time dots in between. Because you're saying 3 squared times 2 times 5 is 90. That's the guts of a 90. The makeup of a 90. Is that good to there? See how we did that? If you broke it down some other way, you'd get the same answer. Like if I went over here and said, well, I'm going to do, I don't know what, 3 times 30. That's okay, just keep going. 5 times 6, right? 6 is 2 times 3. What do we get? 2, 3, 5, 2 threes, a 2 and a 5. See, same answer. It doesn't matter how you break down the 90. If you keep going until you get to the primes, you're going to get the same exact primes. 2 threes, a 2 and a 5. In fact, there's a fundamental theorem of arithmetic which says no matter how you break down a number, there's only one way to break it down to primes. Every number is made out of primes in one unique, it's like a DNA stamp, a unique way of building every number out of primes. We good there? Let's 100. Okay, try that one. The 200 there. So number ends with zeros. Whenever you end with zeros, I just pull off the 10 or 100 or whatever. That's 2 times 100, right? Notice that with 90, I did 9 times 10. So whenever they end with zeros, I just pull off a 10 or pull off 100. That's usually the easiest way to begin. Keep going.
When it says type the factors and, wait.
Oh, from smallest to largest. I didn't
mine-
notice that.
Mine says factored form.
You on number 14?
13.
Yeah, so that's the one we just did?
Yeah. Does that mean that I have to put it in exponents?
Yeah, right, it
does. Oh.
Yeah, you can't go too, yeah.
Okay.
Oh, is it 2 times 2 times? Oh, 9 breaks down. Is that 9? Further?
Oh, yeah, okay. Thank you.
Yeah, then you gotta do the powers, yeah, so it does, you do have to do the powers. So if you have a repeated, like 2 2s or 2 3s, you gotta write 2 squared, or 3 squared. You do have to show the powers. All right, so keep going on that 100. 10 times 10. And the 10 is 2 times 5, 2 times 5.
Times 5 squared.
Good job, right? Because we have 1, 2, 3 2s and 2 5s.
It's kind of cool how no matter what you start with, it all kind of comes down
Yep.
to those round numbers.
It'll always come down to this, because those are the building blocks of the 200. The 200 is made out of 3 2s and 2 5s. There's only one unique way to make a 200 out of primes. That's his DNA code, so to speak. Is that good? We got that? So try 374. So break down the 374. So breaking down the 3, I would usually, I don't even know. When I look at 374, I don't know what's in there. I would just start with 2. Just divide by 2. That's something else, I don't know. 37, 37, 37. 187, is that what you said? Yeah. And then keep going. Does 187 break down?
I don't think so.
It might. You better check it. I'm not sure. I'm really not sure. I would try dividing by 3, by 7, by 11, and by 13. No? Nothing?
34, 11.
Oh, 11 goes. Okay, yes. You just never know. You know, there's some kind of weird numbers out there. That's 11 goes, huh? What? It's 11 times 17, 170. Oh, yeah, it is. Now, those are done, right? So there we're done. So then the breakdown of the 374 is 2 times 11 times 17. That was a weird one. We good? So do you understand why I decided to try 3, 7, 11? Because those are the weird other primes that might go in. I knew 5 didn't go in, so I didn't try 5. But I tried the weird primes. I just don't know all the numbers that go into all the numbers without trying them on my calculator. Okay, 114. So take 114, break it down. What do you know for sure goes in? 2, right? The end's even. Start with 2. Divide by 2, see what you get. Two times 57. Now, is anything going to 57?
Yeah, 19.
Oh, divide by 3, because you add up the digits, it's 12, huh? You know, 12 is divisible by 3, so is 57. Yeah, divide by 3, it's 3 times 19. And there it is. The breakdown of the 114 is he's made out of 2, 3, and 19. Every number's made out of primes in one unique way. 2 times 3 times 19. We good to there? All right. All right, try that one. So try the 980. It'll be like one of the worst ones. So when you see that 980 ending with a 0, you know it's times 10, right? 98 times 10. And then break down the 98. What times what's 98?
10 times 98.
2, right, and then break down the 98. 2 times 49? And the 10 is 2, 5 or 5, 2? Yeah, and the 49 is 7, 7. Should get it all. 2, 7, 7, 2, 5. So the breakdown is 2 squared, 7 squared, 5. Any order. You can put that in any order you want. Well, actually, they say smallest to largest, so I guess I better follow the instructions. There. The 2, then the 5, then the 7. Maybe they'll mark. Will they mark me wrong if I actually switch the order on those?
Probably, yeah.
All right, I better obey the instructions. My wife kids me that I don't obey instructions or road signs and things. I'm always like, that's a silly rule. We don't need to do that. My wife must follow the rules. And I'm like, well, you know, put them in order. It's a dumb rule. So, there, I guess we better obey the rule there. Put them in order like they want us to.
I
There we
didn't
go.
stop at a stop sign in a shopping center.
You didn't stop
I
aside?
didn't,
Yeah.
because there was nobody there.
Yeah.
Boy, did I get yelled at by some old guy.
Oh, really?
He goes, you do that all the time? You always run through the stop signs? And I said, yeah, a lot of times, sorry.
You're honest. I appreciate that. That's good.
There's people that will say, oh, you blew through that stop sign like you never even hesitated before going through.
Now, they're going to say find the greatest combination. So we're going to take 125 and 343. Oh, and we have to do the prime factorization?
Yeah, it wants you to go through each one and then GCF.
All right. Because I have a quick way to jump right to the final answer. I don't have to do that whole prime thing. All right. We'll do their whole thing. So, all right, so let's do the tree thing again. Do the tree thing for both of them. All right, so do that first. There's an easier way. All right.
Mr. Yang taught us that one too.
Yeah.
You know, we drafted it down.
Yes. That's what I'm going to do. Yeah. You guys had Jim Yang? It was Jim. We have two Yangs here. We have David Yang and Jim Yang. You guys had Jim Yang? Yeah. He helped me get the whole iPad thing going. He and one other professor are the ones that gave me the idea. All right, so the 125 is 5 times 25, and 25 is 5. Good on that one? 343.
Yeah.
I don't know. 3 doesn't go. Try. Is that what 7? Yeah, so try those weird numbers. Try, 3, 7, 11, 13. So 7 goes. 7 times 40, oh, okay.
7, 7.
And then 7, 7 again. Yeah.
So what,
Good so far?
yeah,
So the 125 then is what? 5 cubed. And the 343 is 7 cubed.
Oh, this is
Yeah, right. So those are the first. They're going to ask you 3 questions. They're going to say, first off, what's the prime breakdown on the 125? They're going to say, what's the prime breakdown on the other one, the 343, 7 cubed? Then they're going to say, putting that all together, what's the GCF?
Seems like there isn't one.
Yeah, this one's a dumb question. This first one. Yeah, GCF means what's in common, right? What's in common? What's a good way I could put this. If you have like a number that has a 2 and a 5, another one that has a 2 and a 7, let's say it's 10 and 14, right? Anyway, what do they have in common? Yeah, they both have a 2, right? What if this one has, yeah, well, let's just leave it at that. So what do these guys have in common? This one has 3 5s, that one has 3 7. What do they have in common? Nothing. They don't both have 5s? Only one of them has 5s. They don't both have 7s? Only one of them has 7s. So, but the answer is, well, it's not 0, because 1 does divide into every number, right? 1 divides into all the numbers. So that is a factor, greatest common factor. That's something that goes into all the numbers, so it goes into both them, so that's your answer, just 1. If they have nothing else in common, the answer is 1. But if they have stuff in common, then it's just whatever they have in common. Like, for example, here, let me do a what if. Like, for example, what if the first number, it was 5 to 3, what if the second number had a single 5 and 3 7s?
Yeah.
What if those were the 2 numbers? Instead of just, what would they have in common? GCF would be a single 5. That make sense? What if this one had 5 squared and 7 cubed? What would they have in common?
25.
2 5s, 25. Right? In common. Make sense? So you just take what they have in common. Now there is another easier way, but since we're breaking them down, since they're making us do that prime thing, then from there, the easiest thing is just to look at them and say, what do they have in common? There's a way to do it from the beginning without breaking them down at all, but they're making us break them down, so might as well just stick with this, I guess. A lot of number work there. All right, try that one. So take the 135, break it down. Take the 225, break it down. Break them all down. And then when you're all done, take what's in common. All right. So yeah. All right. So break it down. 135. What's that? 5 times 27, and that's 3 times 9, and that's 3. So that one is what? 3 cubed times 5? You okay there? 3 cubed times 5? For the breakdown of the 135? Let's try the 225. 5 times something. 25. Really? Oh, fit.
5 times 45.
45.
Or you can do it 45.
That's okay. 200, and then 5 times 9 and 3, 3. So that's 3 squared, 5 squared. Like good. And this one's 5 times 9, 3, 3. So 3 squared times 5. So we get this one, this one, this one. We good? So let's put them together. So let's see, we got 3 cubed times 5. 3 squared, 5 squared. And 3 squared 5. All right, what do they have in common? What do all three?
3 cubed, 3.
So how many is it true that they all have 3 threes?
No.
Is it true that they all have 2 threes?
Yes.
Yeah, so that's the greatest amount they have in common. Is 2 threes. Is it true that they all have 1 5? Is it true that they all have 2 5s? No. So 2 3, that's a times there. 2 3s and 1 5 is what they have in common. It's what they all three have. They have more than that individually, but that's how much they have in common. That's the greatest amount in common. Am I confusing you? Does that make sense? Right? Because this is 2 3s, 2 3s, 3 3s, so they all have 2 3s, but they don't all have 3 3s. So they have 2 3s in common. Everybody's got. Like you said, hey, everybody, like you're going on a camping trip, you know, and you're saying, all right, hey, campers, does everybody have at least 2 3s in their duffel bag? Yep, we all got at least 2 3s.
So, okay, for mine,
Uh-huh.
it's saying the GCF for 56, 196, and 28. And the greatest one is 7. But it's saying that that's wrong.
I can't do all that in my head. I can look at it later, but you just need to work it all out, and it'd be the same kind of thing in the end.
So then
Yeah,
I
I got
can,
the same answer, it came out to 45. Instead of-
Yeah, this is 45. This is
Right.
3
They want
squared
the
is
answer
9.
45, they don't want it.
Oh, they don't want it like that? Oh, thank you, Jeremy. Yeah, so they want you to work it back out. What is 3 squared? 3 times 3 times 5, which is 9 times 5, 45. Thank you. I didn't realize. So now they make us go back to normal way of doing it, 45.
so then by looking at that, I can divide 135 by 45.
Yeah, yeah, they're all, 45 goes into all these numbers, right? 45 goes into itself, goes into there, and goes into there. It's the greatest number that goes into all three. That's what it is, yeah. That's exactly what we're finding. We're finding in the end, what's the greatest number that goes into all three.
That's the whole purpose of greatest common factor.
Yep, finding the biggest number that goes into all three. I mean, like 5 goes into all three of those. But what's the greatest number that goes into all those? 45. Yeah. We found it by breaking them down to primes and then taking the prime building blocks they have in common. See, that's how we really found it. They're all made out of primes. So there's power in finding the prime breakdown, isn't there? When you find the prime breakdown, then you find out what goes in common, what primes they have in common. All right, 23. 12ab squared and 28 a cubed b. So basically the letters are already good. They're in prime form. We don't need to do anything with the letters, but the numbers need to break down. So break down the 12 and break down the 28. So go ahead and break down the 12, break down the 28 like we've been. Same way we've been.
Would it get to the point that we're gonna have to break down the powers then?
No, because they're already telling us what they are. Yeah, right, this is already telling us I'm 1A and 2 Bs. Nothing more to the story, yeah. So break down the 12. Twelve is 4 times 3. And the 4 is 2 times 2. So we've got the 12 is 2, 2, 3. Does that make sense? So in other words, this whole thing is 2 squared times 3 times AB squared. Everybody good there? Oh, you know what? We're probably doing overkill. Hold on. I didn't realize all that. Never mind. Well, and here's why. Because they didn't say I had to break the prime down. See that? They just say, give me the final answer. So I'm going to show you the quick way then. See what I mean? They just say, greatest common factor, like, boom, final answer. Whereas the last one, they said, okay, give me the first prime breakdown, right? And then they're going to do the second and the third, and then the final answer. So I showed you the whole long way. But they just keep changing their way. So on this one, I mean, this is true. What I did is true, but why mess around? If they're going to just let us go right to the final answer, let me show you how to get there quick. So if they're just going to say, okay, I just want the final answer. So 12ab squared and 28a cubed b. They want the GCF, the greatest common factor. So you just look at the 12 and the 28, and you ask yourself, what's the biggest number that divides evenly into 12 and 28? 4, right. You guys with me on that? 4 is the biggest. You can just calculate it if you're not sure. 4 is the biggest number that 28 and 12 are both divisible by. Just try it on your calculator. That's all I would do. Now, that's for the numbers. How about the letters? What are we going to do for this A, B stuff? Well, you know what's in common. Do what we did with the numbers on the last problem when we had all the powers and everything at the end. How many A's do they have in common? Yeah, you take the lower amount, the regular A to the 1 or regular A, right? Because that's the amount they have in common. How many B's do they have in common? Just 1. That's the GCF. Does that make sense? Because whenever you're talking about what people have in common, you're taking the lower amount, right? If this guy has 1A and this guy has 3 A's, they both have 1A. That's what they have in common. It's the lower power. So you take the lower power on each letter. Each letter, that's the amount in common. That's the amount in common.
So for argument's sake, if they had both had b squared, then our GCF would be 4ab squared. Is that right?
Yes, well said. If they both had b squared, then it would be 4ab squared, because that would be the lower, they'd have in common b squared. They would both have that in common, wouldn't they?
If you did it the factoring way,
Yeah,
you wouldn't come out with 4, because
you would. The 12 would be 2 squared times 3, and the 28 would be 2 squared times 7.
yeah,
Okay, and what do they have in common?
2 squared,
Which is?
4, okay.
Yeah, so either way, it'll work out the same.
Okay. So could the answer be 2 squared AB?
Well, but they don't want you to write it 2 squared, they want you to write 4. Yeah.
Because that is the bigger, okay. That's bigger than 2. It's a bigger number than 2 squared. It's still the same though.
It's the same number.
Yeah.
Yeah, 2 squared is 4. Okay, so let's try. All right, try that one. So 35a cubed b, 40a squared b squared, 45ab cubed. So find a number. Use your calculator if you're not sure. Find a number that divides into all 3 of those. What are those all 3 divisible by? Yeah, 5. Good. You good with that? So 5 is huge 5. Okay. And now you know what to do for the A's and the B's and the powers, right? You take the lowest A power and the lowest B power, because that's what they have in common. So what's the lowest A power you see? Just regular A. Yeah, 1. Yeah. What's the lowest B power you see? Just regular B. Right? This one's just regular B. 5ab, that's it. Because that's all they have in common. They don't all have a squared, do they? because one of them has only one A. Goes with me? See how the lowest power is the amount in common? Is that good? If you had enough math, 4 hours, about enough for the day? Is that that's your limit?
Yeah, we're gonna think about it later too.
Oh, yeah, I know you will, huh? This is a crazy, crazy math summer for you all. All right.
And it makes it easier because it's like you're focusing only
Hey, how
on
many-
the math.
I know. My pass rates are always way higher. I think it's a great plan. All right. Clicker time. Click A for Apple. You get your free clicker quiz. And we are done. So these 3 sections, we finished them all. They're all due as homework on tomorrow, Thursday. Even 5-1. Even though it's 5-1's on the test, we need to keep the train moving. So even 5-1 will be due tomorrow. Tomorrow's Thursday? Yeah. And then tomorrow we'll take our practice test, right? Tomorrow's our practice test.
What are we clicking?
A for Apple. So tomorrow's the practice test. Friday's the real test on graphing. I blocked Jose's there. We're all good. 14, 105, 6, 7, 8, 9, 10, 11, 12. Yeah, all 14 are in, so you're all in. All right, good. We are done.